In our previous packets, we were able to establish that the limit as theta goes to 0 of sine theta divided by theta equals 1. Looking at another question, the limit as x approaches infinity of sine x over x. Well, where's that go? Well, I'm going to apply a theorem that's called the sandwich theorem, and I am not making up that term. And what the sandwich theorem says, if I have a function and I know it is bounded between two different values, okay? For instance, I know that the range of the sine function is always between -1 and +1. So quick sine graph. Okay, so it goes up to 1, it's down to -1. So that's established. But that's not the function I'm trying to deal with. I'm trying to deal with the sine of x divided by x. Well, if I take and I divide by x on each of these terms, I would have my function that I'm trying to work through bounded by two other functions, okay? So if I take the limit on each of the three terms, I can establish that I have a fraction on the first one that is -1 over x. Well, if x gets big and it's in the denominator, that fraction is going to eventually go to 0. So if I put in the infinity on the center problem here, well, I don't know what the sign of infinity is. It fluctuates between -1 and 1. I know that x goes to infinity, but I'm just going to leave that alone for a minute. The third term is just like the first term that we dealt with. The limit as x goes to infinity of 1 over x is still going to go to 0. So here's where the sandwich theorem applies. I have the function that I'm trying to work with, and I know that function is sitting in between a definite number on its lower end and a definite number on its higher end, and those two numbers are both zeros. So if the limit as x approaches infinity of sine x over x is greater than 0 and less than 0, it must equal 0. So the limit as x approaches infinity of the sine x over x is 0.